Question 1 asks for what depth of a 10 by 15 pan will be filled if we know that a brownie recipe makes a mixture that fills up a 9 by 13 inch pan to a depth of 1 inch. So first, let's find the volume of this first pan with the brownie. So we know that volume is just multiplying all of the sides together. So you have 9 times 13 times 1, that is equal to 117. And then we know that if a brownie mixture resulting from 1.5 times the original recipe is poured into this pan, so 1.5 times, we want to multiply 117 by 1.5 to get 175.5. And then this is going to be our volume of the brownie. So we want to see how deep or how high this brownie will be if it's in a 10 by 15 inch pan. So we can just first multiply 10 times 15, and then we're going to multiply by 1 because that 1 is just going to represent 1 inch. So basically for every inch of the pan, of the 10 by 15 inch pan, then you can fit this many square inches, or cubic inches of a brownie. So now we're just going to divide our volume by 150 to get 1.17, which is just the depth, and that's also our answer. This is in inches. Okay. So question 2, real numbers a and b satisfy the following equations. So we know that 3 to the power of a is equal to 81 or whatever. So 81 is just 3 to the power of 4. So we can multiply this by b plus x, well, 4 times b plus x. So from this, we can see that our exponents will be equal to each other since they have the same base. So a is equal to 4b plus 8. And then for the second thing, we know that 5 to the power of a minus 3 is equal to 125 to the power of b. So 125 is just 5 to the power of 3. So we have 5 to the power of 3b. And again, we know that the two exponents are equal. So a minus 3 is equal to 3b. Now we're going to use substitution to solve for b. We're going to sub in this thing for a. So we have 4b plus 8 minus 3 is equal to 3b. And we can solve for b, and we'll find that b is equal to -5. And then you can solve for a, plug it back in, and you'll get a is equal to -12. So since the problem is asking for a times b, you just have to multiply these together. So -5 times -12 is just 60. Question 3. So you have an isosceles trapezoid, and I'm going to draw that. Okay. This is not drawn to scale. Okay, so you have an isosceles triangle, trapezoid, with legs of 30 centimeters. Hold on. So these are legs, by the way. And the longer base is 50. So this entire thing is 50. And we know that, well, we don't know what this is. And yeah. Okay. Wait, let me first draw the diagonals. Yeah, we also know that the diagonals are both 40, 40, and 40. And we know that this height, the height of the thingies, of the trapezoid, we're just going to call that h since we don't know. This is drawn badly. So basically, these heights will form a right angle. And first, we want to find, let's see. Okay. We're going to call this thing x and this thing also x since they're the same because it's an isosceles trapezoid. So that means that this shorter base is 50 minus 2x. And we want to find what x is and h. So to find h, first of all, we can, from this thing, from the side lengths of this triangle, we can see that it is just a 3 by 4 by, it's a 3, 4, 5 triangle. And 3, 5, 4, 3, 4, 5 triangles are actually right triangles. So we can actually find the area of the right triangle. And that's just half base times height. So half 30 times 40, which is 600. And this red triangle's area can also be written as 1/2 times 50 times h, and we can solve for h. So we know that h is 24. And now we want to find x. So we can use the Pythagorean theorem to solve for x. Why are these random dots here? So yeah, h squared plus x squared is equal to 30 squared. And we know that h is 24. And since I'm running low on time, basically solve for x, x is 18. Okay. And now we can find that this shorter base is equal to 50 minus 2 times 18, or that's equal to 14. Now you can just solve for the area of the trapezoid. And it's basically just the shorter base plus the longer base divided by 2 times the height. And that should be equal to, let me calculate it, 768, I believe. This was a long problem. Okay, question 4. Yeah. I'm going to rewrite this equation as a plus 1 over a is equal to 4. And if we square the entire thing, if we square both sides, then we will get a squared plus a times this times 2. That is just 2 plus 2 plus 1 over a squared is equal to 16. So we know that a squared plus 1 over a squared is equal to 14. Now we can square this thing again. We just do the same thing as we did before. And we'll find that a to the power of 4 plus 1 over a to the power of 4 plus 2 is equal to 14 squared. That's 196. And you can you just have to move the 2 to the other side, and you'll get your answer, 194. Okay, question 5. This question has a lot of algebra. Well, just a lot of work. So we know the probability of selecting a red marble is X percent. That is basically X over 100, and basically 4 over 4 plus y. We're gonna call the number of blue marbles y. So okay, and then we know that the probability of selecting one of the 4 marbles, if the number of blue marbles is doubled, is X minus 15%. So this is just X over 100 minus 15 over 100. And this is equal to 4 over 4 plus 2y, since the blue marbles are doubled. And we can use these two equations, I guess. We can use them to form one equation. So how do we do that? We're going to substitute this in here. So we have 4 over 4 plus y minus 15 over 100 is equal to 4 over 4 plus 2y. And now you just have to solve for y. And this will just require a bunch of algebra, and I don't know if I have enough time to write it all out. Okay, we'll just see. So first step, let's just rearrange everything actually. These random dots keep on appearing. I think it's my hand. Okay. So now we just find our common denominator, which is 4 plus x times 4 plus 2. I said x, I meant y. And we have this, okay, yeah, basically just solve for y. And eventually you'll get something like, you'll get 2 possible values for y. You'll have like 4 over 3 and 6. And since a marble cannot be 4 over 3, you have to have a whole number. That means your answer is 6. So you have 6 blue marbles.